All right, ladies and gentlemen, we are looking right now at the topic 11 notes, and we're going to do just a little bit of vocabulary today. All right, so it's not anything super complicated, or it won't be after we're all done. A lot of the stuff today, it can be kind of confusing when you're just looking at words, but hopefully it'll make a little more sense as we start to put pictures with it as well, and especially as we move along through this entire unit. Okay, this is all of the vocabulary we're going to use from now until for the next couple of weeks as we do topic 11 here. So, our first definition, these are not going to go in the same order that they're written on your page. We're going to have to hunt around and go look for them and be very specific about what we're writing where. Okay, that's the point of all this, is to make sure you are absolutely paying attention and you don't get thrown off by going out of order. Okay, you got to actually pay attention and see what's going on here. So, our first definition, half a circle, that is a semicircle. So, as you're looking at your page, it's at the bottom of the first chart. Half a circle is the definition for that. Okay, so that raises the question really, what is a circle? Okay, if a semicircle means half of a circle, what is a circle? And we'll get to that here in a minute. Okay, we'll get to that. Let's look at our next one. The set of all points in a plane that are a given distance from a given point. Okay, so when you look at all the points in a plane that are a given distance away from a certain particular point, that's what a circle is. Okay, so you think about a circle, it's something you could identify when you see it, when you see a picture of one, when you see one, in an example of one in real life of something that is circular, you can point that out, but you need to think about what that circle actually is. It is a bunch of points that are all around the center of it. Okay, all of the points that are around one center point. That's what a circle is. They're all the same distance away from that center. We're going to talk about that more in a second too. All right. So if you're looking at just so that definition of a circle, I want you to write that off to the side on the left, to the left of the circle on top. There's not a specific slot on the table for circle. Okay. So write that definition on its own off to the side. So this next definition, part of a circle or part of a curve, that definition is the definition of arc. So that one's actually down on the bottom table. Arc, part of a circle or part of a curve, is an arc. Okay, so that would just be, in simple terms, it'd be a little piece, just be a little chunk of the outside edge of a circle. All right. So if you have an arc that is smaller than a semicircle, that would be called a minor arc. Okay, so minor arc down at the bottom of your page is an arc that is smaller than a semicircle. Up next, the given point from which all points on a circle are equidistant, that would be called the center. Okay, so when you're dealing with a circle, you have a center point, and all of the points on the edge of the circle are the same distance away from the center. Okay, that's what a circle consists of. It is all the points that are on the outside the same distance away from a center. So that would be center of a circle at the very top of your page. A segment that contains the center of a circle and a segment whose endpoints are on the circle. That is what is called the diameter. Okay, and all of these, as we describe them in words, it's not necessarily going to make perfect sense. Not that this is the most complicated language in the world, but a lot of this is going to make a lot more sense as we look at a picture here in a minute, as we look at pictures of all of these things. Okay, so a diameter is a segment it is a segment that the endpoints are on the edge of the circle, so they're on the circle, and it goes through the center. So this is a diameter is a line segment that goes straight across the middle of a circle. All right. An angle whose vertex is the center of the circle. Like if you made an angle that the point of the angle was the center of the circle, that is what is called a central angle. Up next, arcs that are on the same circle and they have one point in common, those are called adjacent arcs. Okay, that's down on the bottom table on your chart or on your page. Um, arcs that are on the same circle and have one point in common, adjacent. So we've talked about that word adjacent in a couple of different contexts in math, okay? But I want to make sure we understand that word adjacent, that's not just a math term. Okay? That is a regular English word. And, as I talk about it, as I've said in class, if I'm standing next to a desk, I am standing adjacent to that desk. That's what that word means. It just means next to. So when you talk about adjacent in a math sense, like adjacent arcs right here, that is arcs on a circle. They're on the same circle and they're right next to each other. They have one point in common. That's their overlap of those arcs. Okay, that one point is their only overlap. They are adjacent to each other. An arc that is larger than a semicircle, that would be called a major arc. A segment that has an endpoint at the center and the other endpoint on the circle. Okay, so this is a definition that's related to our diameter. Okay, a segment that contains the center and whose endpoints are on the circle is a diameter. So a diameter goes across the whole circle through the center. This next one goes from the edge of the circle only to the center and it stops. It doesn't go all the way across. So that is called a radius. And you're going to see as we move along, as we talk about it tomorrow, the radius is half of the diameter. And that makes sense because you're not going all the way across the circle. You stop right in the middle. You stop at the center, so you only get half of that distance. That would be the radius. And our last one is another one that does not have a slot on the table, but it does have a place down at the bottom of the page where you can write down the definition and leave some room for the drawing. Circles that lie in the same plane and have the same center. That is concentric circles. That's what that word is, concentric. Okay, so circles that lie in the same plane, have the same center, would be concentric circles. You can pause this video right now if you're still, if you didn't get all of those written down, that's perfectly fine. Y'all are at liberty to pause and restart and go back over this video as much as you want to. That's why I'm doing it, is so you can get this done on your own pace if you fell behind in class or if you missed out in class. All right. So I'm going to go on now to look at what some of the pictures of this stuff looks like. Okay. So on the first picture, on the first circle that's on your page, the first picture of a circle that's on your page, I want you to go ahead and mark the center point that's already on there. That is point A. Okay, that point right there in the middle, that is point A. And in fact, in the naming column of your page, that's what we're going to put right there. The center of the circle, that's point A. Now, I also want you to draw on the circle point B, point C, and point D. Points B, C, and D are all going to be points that are on the edge of the circle. Now, there's a very specific way that we have this set up, and you can see it on the screen right here, and there's a reason that we have it set up that way, and you'll see in a minute, okay? Point B is straight to the left of the center. Point C is straight to the right of the center. Point D is somewhere just kind of vaguely up on top, somewhere just kind of hanging out up here, okay? It does not have to have a specific location, but B and C need to be straight across from each other and across from A. Okay, and the reason we're doing that, we'll get to in a second. So our next one that we're looking at would be this right here, the central angle. The central angle, if we were giving an example of that, would be angle DAC. Now, y'all remember how we named angles. Okay, it's the same, the way we named angles was the same way that you would go if you were tracing the angle with your finger. We would go through point D, and then through point A, and then through point C. If we made that angle right there, this angle right in here, that would be a central angle. Okay, that would be a central angle, angle DAC. Up next, let's talk about the diameter. Okay, the diameter is a line segment. That's what we just wrote down a minute ago. The diameter is a line segment that goes from one point on the circle to another point on the circle. and it also goes through a point. It goes through the center point. So in this example right here, you would say that the line segment going from B to C, that is your diameter. Line segment BC. That's your diameter. Up next is a radius. A radius would look something like this right here. It's the distance from a point on the circle to the center. So if we started here and went straight up like that, that green highlighted line right there, line segment AD, that would be a radius. So there you've got 4 different names and different pictures all on that one circle of items that we just defined. Okay? Hopefully, this picture is going to do just as much good explanation as just having the words. Okay? A lot of times, having that picture, I know so many people are visual learners, so that could really help with putting an idea with the words that describe it. All right? Let's go on to, let's take a look at the other circle now. We're going to draw some more. Okay, I want you to put points A, B, C, and D around the edge of the second circle, A, B, C, and D, and try and arrange them, if you would. Try and arrange them pretty close to the where they're set up on this picture, okay, because that's going to affect, when we talk about major and minor arc, is going to, where they are placed is going to affect that. So when we talk about an arc, that is the distance between 2 points that are on the edge of the circle. Okay, so for example, if we drew arc AB, here's what that would look like notation-wise. You've got your 2 points, A and B, and you've got a little arch top over the top of them. Okay, y'all remember how we had line segments, had the little line on top of them? If it was a line, it had the 2 arrows. If it was a ray, it had 1 arrow, stuff like that. Okay, the notation for an arc is to just have that little bitty little arch top thing right there on top of the 2 points. All right, so that is the arc in between A and B. Adjacent arcs. Okay, we talked about that word adjacent, just means next to. I'm going to do this in different colors here. So if we did arc DA and arc AB, those 2 arcs are right next to each other. They're both part of this same circle. They're both a part of this whole circle. This arc is this piece right here, DA, and arc AB is the one down here that's green. They would be adjacent to each other, and they share point A is what they have in common. So those would be adjacent arcs. Up next, let's look at a major arc, and it gives us this example of arc ADC. Okay, so think about what that means. If we're going arc ADC, we start at A, and we go all the way around to C. Now, when you look at arc ADC, the one that I just highlighted in blue, starts at A and goes all the way around this way, you can tell that that is more than half of a circle. Okay, this is more than a semicircle. So that tells us it's going to be a major arc. An example of a minor arc would be that same one that we started with. Arc AB, this one that's already highlighted in green, would be a minor arc. The blue one was our major arc. So there we go. We've got us all the different types of arcs that we're going to talk about, at least here at the beginning. All right. So our last one that I wanted to draw a picture of all by itself is concentric circles. Now I want you to think for a second about what that definition that we wrote down was. We said way back over here that concentric circles down here at the bottom were circles on the same plane and they have the same center. Okay, so think about in your mind what that looks like. You've got two circles that are on the same plane and they have the same middle. So what you really have is just one circle like inside and outside of each other. And it looks like this. Okay? These rings on a target are an example of 10 concentric circles. Okay? They're all in line with each other on the same plane. They're all in line with each other on the same plane, and they all have the same middle right here at the bullseye of that target. Right there in the center is the middle of every single one of those rings, right? So that's one example of what concentric circles would look like. All right, so that's all we've got for today. That's all we're going to look at for vocabulary. We will start on a full-on brand new section of the notes starting tomorrow. Y'all have a good one.